A star lit up, died, and may have exposed one of the most wanted invisible objects in the universe. Not a giant black hole in a galaxy's core, not a small one left behind by a dead star. Something in between, something missing. That something is AT2024tvd, a violent flare spotted in 2024 inside a globular cluster in the galaxy NGC 6099. And if astronomers are reading this cosmic crime scene correctly, a hidden intermediate mass black hole may have torn a star apart there. A black hole too massive to be stellar, too small to be supermassive, and exactly the kind of object astronomy has been hunting for decades. This is the core idea. Intermediate mass black holes are the missing middle of black hole evolution. We know small black holes exist. We know supermassive ones anchor galaxies. But the middle class has stayed strangely elusive, like finding baby footprints and adult footprints, but almost none in between. And AT2024tvd matters because it may be the cleanest evidence yet that one of these hidden killers was lurking in a globular cluster, waiting for a star to pass too close. Picture the setting. A globular cluster is an ancient swarm of stars, tightly packed, dense, almost fossil-like. Some contain hundreds of thousands of stars, all gravitationally tangled together. They are beautiful from far away. Up close, they feel less like a calm jewel box and more like a crowded city where gravity never sleeps. For years, astronomers suspected these clusters might hide intermediate mass black holes. The logic is seductive. In such dense stellar environments, repeated collisions and mergers could build something larger than an ordinary black hole. But proving it has been maddening. Why? Because black holes do not shine on their own. If they are quiet, they are basically cosmic ambush predators. Then came the flare. In 2024, astronomers detected AT2024tvd as a transient event, a sudden brightening, not just random flickering, something dramatic. The signal appeared associated with a globular cluster around NGC 6099, roughly 450 million light-years away, according to reports built from follow-up observations. That distance matters. We are not looking at a neat laboratory demo. We are reconstructing a murder from a flash that crossed almost 500 million years of space. At first, there are several suspects in any flare like this. A supernova, an active galactic nucleus, some odd stellar eruption. Astronomers have to eliminate them one by one, like forensic detectives checking alibis. A supernova is an exploding star, yes, but supernovae follow patterns in brightness and spectral evolution that often give them away. An active galactic nucleus comes from matter feeding a supermassive black hole in a galaxy's center. But this flare did not seem to sit in the galactic nucleus. It pointed instead to a globular cluster away from the center. That is a huge clue. If the source is truly inside that cluster, the usual explanation breaks. And once the usual explanation breaks, the missing black hole hypothesis suddenly stops sounding exotic. What may have happened is chillingly simple. A star drifted too close to an unseen object. Gravity stretched it, compressed it, and then shredded it in a tidal disruption event. A tidal disruption event is what happens when a black hole pulls harder on one side of a star than the other. the star is no longer a star at all. It becomes a stream of debris. Some of that debris escapes. Some spirals inward, heats up, and blazes across space. That blaze is the clue. And personally, this is what I find so haunting about black hole astronomy. We almost never see the killer. We see the wound. We see the ash. We see the last scream converted into light. So why does this point to an intermediate mass black hole instead of some other monster? Because location changes everything. Supermassive black holes live in galactic centers. Stellar mass black holes are usually too small to generate the same kind of event under these circumstances and at this observed scale. Put a destructive flare inside a globular cluster, and you land in an uncomfortable middle zone. The exact zone astronomy has struggled to fill. There's also the mass question. Intermediate mass black holes are expected to sit roughly between about 100 and 100,000 times the mass of the Sun. Stellar black holes are typically below that. Supermassive black holes start millions of solar masses and go absurdly higher. This middle range matters because it may tell us how the largest black holes in the universe were built in the first place. Did giants grow from mergers of smaller seeds? Did some form directly from giant gas clouds in the early universe? You cannot answer that cleanly if the middle stage is missing.
So, let me ask you this. If you had to bet right now, do you think AT2024tvd is really the signature of a hidden intermediate mass black hole? Or do you think astronomers will eventually pin it on something more ordinary? Tell me in the comments before we get to the most unsettling part. Because the most unsettling part is not just that a star died. It is that one death may reveal an entire hidden population. For decades, astronomers have reported hints of intermediate mass black holes, but so many of those hints came with caveats. A velocity dispersion here, a suspicious radio source there, a cluster whose stars move a little too fast near the center. Intriguing, yes. Clean, decisive? No.
Some candidates have later looked less convincing under better data. That has made the field feel almost cursed. AT2024tvd is different because tidal disruption events are harder to ignore. They are dynamic, violent, timed. You can model them. If this really was a star being torn apart inside a globular cluster, the invisible object responsible starts to look less like speculation and more like a perpetrator with fingerprints on the glass. A 2020 review in Astronomy and Astrophysics by Green, Strader, and Ho laid out the problem clearly. Intermediate mass black holes are one of the most important missing links in black hole astrophysics. Missing link is not hype here. It is almost literal. We have the endpoints. We do not have the bridge. A 2019 study led by Karen Holacek and collaborators modeled tidal disruption events in globular clusters as a way to reveal these hidden objects. A 2024 event like AT2024tvd is exciting precisely because it drops a possible real-world case into that theoretical gap. And I think that is why this story hits harder than a normal discovery claim. It is not just, we found a weird object. It is, the universe may have shown us one only because it killed a star in public. Tone shift, building. Urgent. But wait, there is a twist that makes this even bigger. If AT2024tvd really came from an intermediate mass black hole in a globular cluster, then these black holes may not be rare curiosities at all. They may be quietly scattered through ancient star clusters across the universe, almost impossible to see until something wanders too close. Think about what that means. Not one invisible executioner, potentially many. How many stars have already been swallowed in silence? How many clusters hide dark centers that we have mistaken for ordinary gravity? And how much of cosmic history have we misread because the killers left no light behind? There is another layer here. Globular clusters are old, very old. Many formed more than 10 billion years ago. If intermediate mass black holes have been sitting inside some of them since the early universe, then they are not just missing objects. They are ancient survivors. Fossils from a stage of cosmic growth we still do not understand. That possibility connects one dead star to a much larger question. How did the first supermassive black holes appear so early? The James Webb Space Telescope has found very massive black holes already in place in the young universe, at epochs that make theorists uncomfortable. Some were too big, too soon. One way out of that problem is to start with heavier seeds. Intermediate mass black holes are among the strongest candidates for those seeds. If that possibility surprised you as much as it surprised me when I dug into this case, leave a like, because one shredded star may be telling us how the biggest black holes in existence got their start. And yet, caution matters. Good astronomy is not wishful thinking with prettier graphics. AT2024tvd is a candidate, not a final verdict. Astronomers still need more spectroscopy, more host environment analysis, more comparison against alternative transients. Could there be another explanation? Possibly. Science earns confidence by surviving doubt. Confession time. I actually like that uncertainty. Not because ambiguity is satisfying, but because it reminds us that discovery is usually messy. The clean version only shows up later in textbooks. In real time, it feels like standing in the dark, staring at a blood trail made of photons. My view is that events like AT2024tvd are probably the most honest path to finding intermediate mass black holes. Not by waiting for them to glow politely, but by catching the damage they do. That is a grim idea. It is also, in my opinion, one of the most revealing. The universe often explains itself only through catastrophe. And maybe that is the real payoff. We like to imagine the cosmos as a grand, illuminated map. Stars, galaxies, nebulae, all shining helpfully in the dark. But a huge part of reality may be structured by things we cannot see directly at all. Things that shape motion, trigger death, and leave us to reconstruct their existence from aftermaths. AT2024tvd may end up being revised, narrowed, or even overturned. That happens. But if the interpretation holds, then one doomed star inside a distant globular cluster has done something extraordinary. It has pointed at one of the universe's missing black holes and said, "There." Not because the black hole chose to appear, because it failed to hide the violence this time. So the story is bigger than one flare. It is about the terrifying possibility that the universe is full of invisible thresholds, places where an ordinary orbit becomes a death sentence. It is about how much power can sit in darkness for billions of years. And it is about how human beings, absurdly small on the cosmic scale, can still read the evidence. When I think about that, I do not just feel awe. I feel something sharper. Humility. Because out there, entire stars can disappear into objects that produce no light of their own, and we only learn their names from the ruins. If mysteries like AT2024tvd fascinate you, subscribe and join this channel. We chase the parts of the universe that hide in plain darkness, and the next story may be even stranger than a star exposing a black hole nobody could see.